Okay, so yesterday we talked about z-scores and we had a formula. There's actually two formulas for this unit. The first one that we had yesterday when we were looking at z-scores, we had z is equal to, we took the distance that our sample proportion was from our true proportion that they were claiming, and we divided by our standard deviation, which happened to be this formula. So you take p times 1 minus p and you divide by n. So you should have practiced that 4 times yesterday, once in notes and then 3 other ones in the lesson. The second and final formula of our entire year actually together is this right here. We're going to build what are called confidence intervals around this proportion that we're going to find. And the way that we do that is we take our p hat, our sample proportion, and we add and subtract a little bit. And I'll show you with a example what that actually means. But we're going to take our sample proportion and build plus or minus, okay, this proportion around it, saying, well, we're 95% confident that based on our sample proportion, we're going to add and subtract this number and say that we know that the true proportion would be between these two values. Like our actual p will be between two values that we get from this formula. That's what a confidence interval is. We're going to be using, you'll notice in here I put that our z star that they have in this formula will always be 1.96. So I'm just going to do that now. We're going to always build 95% confidence intervals. Think about yesterday when we rejected this. Okay, and we said, oh yeah, no, it was way different than what the proportion was. Our confidence level is at what we call a 5% level. That's kind of the make or break in real life, in court cases and everything. This 5% level is the break even. So here, we're gonna do what's called a 95% confidence interval. Like we are 95% sure that it's between these two values. Okay, so we take 1.96 and then you'll notice this looks very similar, and that's why I'm relating it back to this one times this standard deviation here. Now in this one, we won't know the actual p-value. So we can't do the same standard deviation that we have here because what we're trying to figure out is what is our actual p. And the only thing we're going to have in these problems is our p hat. So that's what we use for our standard deviation here. So you'll notice the difference there. Okay, is that now in this standard deviation, we used our actual p. We were going to assume that what they said was true, and then we're trying to prove that it's either less than or greater than that. Okay, but we use our actual p in this one, but in this standard deviation, it's the same formula. It's just that the only thing that we have is this sample proportion. So let's get on to an example so we can see what this means. So binge drinking. In a recent national survey of drug use and health, 2,312 of 5,914 randomly selected full-time U.S. college students were classified as binge drinkers. So based on that proportion, we want to know, well, what is the true proportion? Because like, okay, I'm going to give my sample proportion right here. But based on this, what is the true proportion of students? True proportion of students that are labeled or classified as binge drinkers. So we're going to take our 2,312 and divide by the 5,914. This will give us the proportion that are labeled or classified as binge drinkers. So I'm going to grab my calculator. 2,312 divided by 5,914. I get that the proportion is 39%. 39%. Now, that's my sample proportion, that hat, okay, sample proportion. So we're going to try to estimate what's called the true proportion based on this sample proportion. So this is how we do that. We use this formula, okay, which is what I'm going to use down here. I take my 39% and I'm going to add and subtract a little bit. Okay, this little bit that I talk about has this formula where we actually use what's called the standard error. But we're going to add and subtract a little bit to say, well, based on our sample, and this was a really big sample, so this is going to be a very, what we call small window. Okay, I'm adding and subtracting a little, and I'm going to be 95% confident that the true proportion is between these two values. That's what we're doing here. So that's where the plus and minus come in. And then I have my 1.96 times my standard deviation. We call this standard error because it's a sample, but we have 0.39 times 1 minus 0.39. Okay, so 1 minus 0.39 is 0.61. Okay, and then we divide by the total number of people, 5,914. Okay, so I'm going to do this example here. We have 0.39 plus or minus 1.96 times, and now you're going to see me do the math for my standard deviation. This is the same as yesterday, 0.39 times 0.61. I do that first and hit equals. Then I divide by 5,914. I hit equal again. I will flip my phone and take the square root, and I get that number. That number is very small, and I want you guys to know something about this. I knew it was going to be that small. The reason I knew that is because this is a really big sample. When I get these numbers, they're going to be very close to 0.39 because of how big of a sample. Big samples are really good because we're going to get a very small deviation from that. In at least one or two of the examples that you guys do, you're only going to have 50 or 100 people in your survey. You're going to see this window get really big around that 39%. Okay. Okay, so now I'm going to finish up, do the last little bit of math here. So I take that 0.006. I'm going to now multiply times 1.96. Okay, that's going to be my 95% confidence level. And what I have is 0.39 plus or minus about 1%. Plus or minus, and it's a little bit more than that, but I'm just going to round it to 2 decimal places because I understand this right here. That means that my window is going to be 0.39 minus 1%, 0.38, and 0.39 plus 1%, which is 0.40, 40%. Okay, so what this will mean is that when I talk about it, we are 95% confident that the true proportion, okay, proportion, which is that p-value, not the p-hat, because we based it on our sample. This is p-hat, but our true proportion is between 38.38 and 0.40. Okay, so between 38 and 40% of US college students are going to be classified as binge drinkers between these two values based on our sample of 39. So that's how you do that example. I do want to show you that on homework, you're going to have much larger windows than that. That was literally between two percentages. Look at this one. When you do your first one on homework tonight, you get between 60 and 84%. And the reason that that window is so big, because that doesn't really give me that much information, is because if you look carefully, we only sampled 50 people. The more people that you get in a sample, so this one was 172 and it narrowed that window a lot. Okay. The more people you sample, the better the data that you get, because now I know it's between these two values. That's a lot more useful than saying between 60 and 84%. That doesn't really tell you much in real life. Okay. So that is what you're doing tonight. Again, pop down to the video down below if you need help with number 4, 5, and 6.